What probabilities are is actually quite a difficult question to answer. It's a philosophical question. And really the only thing I can tell you with any confidence is that people don't agree on the answer. There are several theories, the simplest of which is that of equally likely outcomes. Your experiment results in a set of outcomes, and you have some reason to believe that they're all equally likely. Perhaps for some physical considerations, you feel that no one outcome has a different status from any other. Typical example is rolling a die. The die is a little cube that has 6 faces, and on the 6 faces you have spots. 1, 2, 3, 4, 5, 6 spots. And it's a very natural assumption that when you roll the die, you are as likely to get any face as any other face. And if you are willing to work with that theory, then if somebody asks you for a probability, for example, I'm going to roll this die once, what is the chance that I get more than 4 spots? Then you're going to say, well, that's either 5 spots or 6 spots. So that's 2 faces out of 6 equally likely faces, and therefore the chance is 2 in 6. Simple fraction. And that, in general, can be written like this: if all the outcomes that are possible are equally likely, then to find the chance of any event, you just count. You count in the denominator all possible outcomes, and in the numerator the outcomes that satisfy the conditions of your event. And that fraction is your probability. And the good news there is that's a very simple thing to do, assuming that you are good at counting. The bad news is that's a very simple thing to do, especially that assumption that all your outcomes are equally likely may be very restrictive. Maybe you want a little bit more flexibility than that. And so let's take a situation where people are usually willing to assume equally likely outcomes. That's the coin. You toss it, it lands either heads or tails. Most people are willing to assume, often without much basis, that those 2 outcomes are equally likely. But it turns out also that if you take the ordinary US quarter or many coins, and you toss the coin over and over and over again, then in the long run you get about half heads. And that is a reason the probability of heads is defined as a half. In general, you have some experiment and you are trying to find the probability of an event that is a result of the experiment. You repeat your experiment over and over again under identical conditions forever. The probability of your event is the long-run proportion of times that it happens. Which means this: you keep track of how often it's happening and you calculate the proportion. And if the proportion settles down in the long run, then that's what you define as the probability. Now, there's a lot hidden in that statement. Why should the proportion settle down? I won't go into those details of philosophy as to which is the assumption and which is the conclusion. I'll say only that in Stat 2.2, the probabilities that you encounter will by and large be long-run frequencies, because we will be doing things like tossing coins or drawing individuals at random from populations, and you can imagine doing that over and over and over again. With the caveats that indefinitely is a very long time, and we are all going to be dead long before indefinitely. So it's a nice idea in theory, but you really, in practical terms, are going to have to imagine that proportion settling down as you approach the long run. Also, not every probability you want to talk about comes from an event that is to do with an experiment that is repeatable. The typical example is sporting events. People bet on sports all the time. This team is going to win this championship. All the time. But can you repeat that championship game indefinitely under identical conditions? Well, of course you can't, because those poor athletes are going to drop down dead out of exhaustion. And yet people talk about those chances all the time. So those chances aren't long-run frequencies. What are they? They're opinions. That's perfectly fine. Somebody's opinion is, somebody says, I bet my team's going to win, and their friend says, no chance. Both of those people have expressed probabilistic opinions, and they have subjective probabilities. Your subjective probability is your degree of belief that an event might happen. So, for example, if you've got no clue about the event, you have no specific knowledge about it whatsoever, you might say, I've got no idea. I'm just going to say the probabilities are half. But if you are in some way an expert in a subject area, you might have a sharper idea of probability than that. This subjective approach to probability gives a lot of people the heebie-jeebies, because people want things to be nailed down and scientific, and you know what? It's perfectly scientific if you know what you have done. If you know, for example, that your subjective probability of an event may be different from mine, in which case your answer is different from mine, if you know that and are aware of that, then you can work with it. It's not easy, but it's clear. The one thing to be aware of is that if in a probability calculation you have any ingredient that is subjective, then your answer is going to be subjective. You can't take a subjective ingredient and then do a lot of fancy calculations and say my answer isn't subjective anymore. It still is. It's fine, as long as you know and acknowledge that that's what's happened. For our purposes, as I said, our probabilities that we encounter are going to be mostly, almost invariably, long-run frequencies. And while there's a slew of ideas about what probabilities are and the advantages and disadvantages of the different theories, it is a great relief that there is a common ground that these theories share, which is that the basic rules for how to calculate are the same no matter what you think the probabilities are. And we are going to use that as our basis because we would like to get on to calculating probabilities. So as far as I am concerned, you are free to think of probabilities in any manner that suits you. Some people get terribly het up about whether you should think like a subjectivist or whether you should think like a frequentist. It's a big battle. But most people are relaxed, and I hope you will be too. No matter what you think probabilities are, you'll want to work with them. And that's the business of the next section.